The terms 3, 8, 15, 24, 35 in a sequence are of the form 1 times 3, 2 times 4, 3 times 5, and so on. So write down a formula for the nth term, that's part A. And for the B part, explain why the formula for the n plus 1th term is this, n plus 1 times n plus 3. And prove that the difference between the two consecutive terms in the sequence is 2n plus 3. So what we start with is, we have been given already how the sequence is formed. So 3 is 1 times 3, and then 8 is 2 times 4, 15 is 3 times 5, so 24 would be 4 times 6, and 35 would be 5 times 7, and so on. So therefore it's quite easy to write the sequence in terms of n. So the first term 1, 2, 3, so that is going to be n. So n, and that's n times, and then it is 3, 4, 5. So the sequence 3, 4, 5. So this can be written as, so 3 would be, so if I could write, or I could just do it here. So 3, 4, 5. So we could write this as 3 plus, a plus n minus 1 times t. So times 1. First term is 3 and the common difference is 1. So that would be 3 plus n minus 1. That is n plus 2. So it's n times n plus 2. So the formula for the nth term would be n times n plus 2. So then we need to find the formula for n plus 1th term. So for the n plus 1th term, instead of n, we write n plus 1. So nth term equals n times n plus 2, and therefore n plus 1th term would equal, instead of n, I put n plus 1, and then n plus 1 plus 2. So that would equal n plus 1 times n plus 3. So that's proved. Okay, so then they are saying prove that the difference between the two consecutive terms in a sequence is this. So consecutive terms would be n plus 1th term, or I should write nth term, and the n plus 1th term. So these are consecutive terms of the sequence, and the difference between two consecutive terms then would be, you know the n plus 1th term, and we know the nth term, so it's the difference of these two terms. So difference of n plus 1th term and nth term would equal, you would have n plus 1 times n plus 3 minus n times n plus 2, and that equals n square. So plus 3n plus n plus 4n plus 3 minus n square minus 2n, and that equals, the n squares are cancelled, 4n minus 2n is 2n plus 3, and there's also 2n plus 3, hence proved.